All right, ever find yourself wondering if those think of a number tricks are actual mind reading? We're diving into some seventh grade math today, but trust me, this isn't about reliving middle school. You send over excerpts from simple equations, and I'm curious to see what kind of magic we can unlock.
Well, it's not magic, but it can definitely feel like it sometimes. It's pretty fascinating, actually, how often we use algebraic thinking without even really realizing it.
Right, and the textbook starts with this example of a mind reading game students, Amina and Apu, correctly guessing their classmates' numbers. What's the secret sauce there?
Simple equations. It's all about simple equations. The book sets it up like a game. Amina, she asks her classmate, Sarah, to think of a number. And, well, in algebra, we represent that unknown number with a variable, typically x. Then she has Sarah multiply it by 4, which, in our algebraic terms, becomes 4x.
Okay, keeping up so far. So not really mind reading. It's more like we're talking about a carefully constructed formula.
Precisely. Exactly. Then Amina tells Sarah to add 5 to that, giving us the expression 4x plus 5. And here's the real key. Amina doesn't actually know what number Sarah is thinking, but she does know the result of that calculation because Sarah tells her. She tells her it's 65.
Uh-huh. So now we have an equation. 4x plus 5 equals 65. Is this where we whip out our detective hats and solve for x?
You got it. We essentially work backward to figure out what that x must be to make the equation true. We want that x all alone on one side of the equation, right?
Yeah.
So first we got to subtract 5 from both sides, which
That
gives
was
us
60.
right,
Opal is 60 because, and this is key, what you do to one side of the equation, you have to do to the other, right?
that's the golden rule of algebra.
Yeah.
And to finally isolate that x, we've got to get rid of that 4, so we divide both sides by 4.
Which means x equals 15. So Sarah was thinking of the number 15. See, I told you it wasn't mind reading.
Nope, it's the power of algebra. And the textbook gives another example, this time with Apu. He asks Balu to think of a number, let's call this one Viley, this time multiply it by 10, and then subtract 20. This time, Balu's result is 50.
Okay, so following the same logic as before, our equation would be 10 20 equals 50.
Exactly. And if we just follow that same process, add 20 to both sides, then divide by 10, we find that y equals 7.
All right, I think I'm starting to get the hang of this. It's like a puzzle, but instead of fitting pieces together, we're using math to reveal a hidden number.
Exactly. And what's so neat is that these are just the basic examples. Like, the textbook goes on to show how these same principles can apply to all sorts of problems.
Like actual real-world stuff, not just classroom games.
Oh, absolutely. Like, imagine you're at the grocery store trying to decide if it's cheaper to buy the giant box of cereal or a few smaller ones.
Ooh, this is where my brain goes into overdrive trying to do mental math in the cereal aisle. Don't tell me there's a simple equation for that, too.
There's an equation for practically everything. But before we get ahead of ourselves, the textbook does bring up a really interesting concept called transposing. It's essentially a shortcut for solving equations.
A shortcut, you say? Okay, color me intrigued. Lay it on me.
Okay, so let's say we have the equation 12p5 equals 25. And we know, right, we can solve for p by, like we said, performing the same operation on both sides. But with transposing, instead of adding 5 to both sides to get rid of that messy 5, we can actually just move it to the other side of the equation.
And it just vanishes. That sounds a little too much like magic, even for this episode.
Not magic, I promise, but it definitely makes things a bit more efficient. Here's the catch. When we move a term to the other side, like that negative 5, we have to change its sign so it becomes plus 5 on the other side.
So it's like what? It's switching teams and has to put on a different jersey.
That's a great way to put it. So now our equation becomes 12p equals 25 plus 5, which obviously we can simplify to 12p equals 30. And from there, we just, divide both sides by 12, same as before. We find that p equals 2.5.
Okay. Yeah, that is a pretty neat trick. It's like the streamlined, turbocharged version of what we were doing before.
Precisely. It just goes to show how, with algebra, it's all about finding the most, elegant and efficient ways to solve problems, really.
Mm-hmm.
But speaking of elegant, there's another concept the textbook talks about that I thought was really interesting, the idea of working backward from a solution to create an equation.
Hold on. So instead of starting with an equation and solving for, let's say, x, we start with x and build the equation around it. That's like reverse engineering math.
It is reverse engineering, and it's a really cool way to kind of wrap your head around the relationship between equations and solutions. For example, let's just say we know our solution is x equals to 5, right? We could start by multiplying both sides by 4, which would give us 4x 20. Then maybe we subtract 3 from both sides, giving us 4 by 3 equals 17.
And there you have it, an equation that has x5 as the solution. But here's what I find so interesting. We could have done a totally different set of operations, maybe multiplied by 2, added 7, then divided by 3, whatever. We'd still end up with an equation that has x equals 5 as the solution.
Exactly. It highlights that there isn't just like one right answer, one right equation. There's a whole bunch of ways to get to the same place, which I think is really neat. And in fact, the textbook even suggests, using this to create number puzzles.
Oh, I love that. Like turning math into a game.
Exactly.
Yeah.
Because games are a fantastic way to engage with, these more complex concepts in a way that's, fun and challenging at the same time.
Speaking of games, remember that example about Raju and his dad? That one felt less like a textbook problem and more like a logic puzzle you'd find in a game magazine.
You're talking about example 10, right? Where Raju's father is 44 years old.
Yeah.
And he's 5 years older than 3 times Raju's age. That one definitely had those riddle vibes.
Yeah, it was like those "how old is the captain" brain teasers. So how would we even go about solving that using, our newfound equation building skills?
Well, we don't know Raju's age, so that's going to be our unknown. So we can represent that with a variable y. 3 times Raju's age would be 3y, right?
And since his father is 5 years older than 3 times Raju's age, that means we got to add 5 to that, which gives us 3 plus 5.
And we know that whole expression, 3y plus 5, has to equal 44, Raju's father's age. So our equation is 3y plus 5 equals 44.
And then we just solve for re. It's amazing to me how we can take this whole scenario, this whole word problem, and just break it down into this neat little equation.
Well, that's the beauty of algebraic thinking. It allows us to approach problems, even ones that seem kind of complicated at first, systematically, and then because of that, we're much more likely to actually find solutions.
It's like we have a secret decoder ring for everyday life. But, for all this talk about equations and variables and, the mechanics of it all, the thing that's really striking me is just how practical this all is. It's like you don't even realize you're using algebra and then bam, there it is, right in front of you.
It's true. And we talked about, grocery shopping earlier, but even something like baking, like if you're adjusting a recipe, doubling it, halving it, that's like pure equation work right there.
Tell me about it. That reminds me of one DIY painting project I did. Let's just say I probably should have brushed up on my equations before I bought all that paint. But you're right, these concepts really are everywhere. You just have to kind of open your eyes to them,
And that's what I think is so cool about, taking the time to really understand these basic, simple equations. They really do give you this framework, like a framework for thinking about problems, breaking them down, and then hopefully, actually finding solutions. And that's true whether we're dealing with, literal numbers and quantities or even like just abstract relationships.
It's like having a whole toolbox, right? A whole set of mental tools at your disposal. And if you know which tool to use, suddenly it's like the problem becomes solvable.
Absolutely.
Yeah.
And just like any tool, I think the key is practice, right?
Yeah.
The more you practice, the more you use these tools, the more comfortable you become and the more proficient you become. Like all those examples we were talking about from the textbook, the mind reading game, the mangoes, Raju's age. Yeah, it's not just about, getting to the right answer. It's about building up that mental agility,
So it's less about just memorizing a formula and more about understanding how to think about things.
Exactly. It's about being able to spot patterns, make those connections, and just generally apply logic and reasoning in a really structured, deliberate way.
Yeah.
And those are skills, I think, that really do translate to so many different areas of life, wouldn't you say? 100%. It's like we've been on this journey, this simple equations journey, and we've come out the other side, not just having, reached the destination, but having picked up all these valuable tools and, ways of thinking about things along the way.
And the exciting part is this is really just the tip of the iceberg. I mean, algebra is a huge, fascinating field with just endless applications.
It's like we've unlocked the first level of some super cool math video game.
Yeah.
Who knows what other mathematical treasures are out there just waiting for us to find them.
That's the spirit. That sense of curiosity, that desire to explore, that's key. Seriously, never underestimate the power of asking questions. Asking questions and never being afraid to seek out new knowledge. Couldn't agree more. Well, on that note, I think it's time for us to wrap up our deep dive. But before we go, dear listener, we've got one last challenge for you. Think about it. What seemingly simple concept or skill do you use every day that might surprise people? Something that seems totally straightforward, but underneath the surface is actually way more complex and nuanced than folks might realize. Take some time to really ponder that. Who knows, maybe you'll uncover a hidden equation or two in the process.